Warm up 110. Number 1, still graph the circle. X squared plus y squared minus 16y plus 10x plus 40 equals 0. Number 2, simplify. Use long division. 5x minus 13 over x minus 2. And number 3, simplify. Log base 3. Give it number 81. And number 4, compute the missing length of the triangle. Then identify tangent of angle A. They give us a right triangle with the hypotenuse at the segment BA, starting at the top. That measures 13. And then one of the legs at the bottom is CA, and that measures 5. And the height, or the side, which is BC or CB, is X. So first work on identifying X, and then from there work on identifying tangent of angle A. I'll give you guys some time for that. Copy and go. All right. So let's get this show on the road. Number 1. What'd you get for number 1? Megan. No, she just no, help her out. Caesar. Center and radius of number 1. Negative 5, 8. And the radius? 7. Hands if you got that. That is correct. Negative 5, 8. So, negative 5 is right there. 8 is over here. So it's somewhere up here. Here, 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 and here. And there's your circle. Okay. Number 2, pass someone. Ivan. Number 2.
I got 3.
3.
3, 1 over x. 1 over x.
What? Oh, 3 times. Okay, I see. I see what you're saying. 3 times 1 over x minus 2 plus 5. Hands if you got that. Close. Say near what's missing. A negative. Negative 3. Yeah? Okay. All right. Yeah, so make sure if you have anything other than 1 on the numerator, send that to the front, and the constant goes at the end. All right. Pass someone. Ivan, number 3. Hector. Y equals 4. That is correct. Or another way of rewriting this, log base 3. 81 and base 3 is 3 to the 4th. So since this is the same as this, answer is 4. Number 4, x equals to what? Hector, pass someone. Andres. All right, we'll come back to Andres. And, yeah, so we need that in order to get tangent. So he'll do both things, the x and the tangent. In the meantime, copy the agenda, please. Warm-up number 110, Semester 2 Concepts and Skills. Study guide, tonight's, once again, cumulative study guide. And like I said, today we're going to be working mostly on graphs and transformations. So for those of you that had problems before with that, make sure you take copious notes, stay focused. Hopefully this review is going to help you see the bigger picture of all that. And I'm basically just elaborating and using a lot of words to wait for Andres. And so like that we can go on. In the meantime, also last night was number 6 and 7 for home plate. So go to Canvas, turn that in. It counts as a pop hearted today. Let's go. Let's go. Oh yeah, we got this. Some of you are like, why do you do that, Mr. Q? Because I like that. How about that? How about them apples? That's pretty good, yeah? All right. I like the design of those windbreakers. It looks kind of like a faded logo. Looks like if a tiger kind of like flashed through it like that or something. Right? Yeah? Okay. All right, so let's see. Going back to the warm-up. Who had number 4? X equals 12. Hands if you got that. Close. Units. All right, so with that said, tangent of angle A. So angle A is right there. 12 over 5. And it was opposite over adjacent. Opposite over adjacent. That is correct. Double check your work. And once again, guys, this is number 34 on your final. So if you look at your study guide, you should be able to do number 34 like no problem. Yeah? And of course, number 33 is a unit circle. I'm pretty sure you already have that memorized. Yeah? Yes, Mr. Q. All right, good. All right, so with that said, you're turning in your home plate, which was problems 6 and 7. And get a Cornell note ready. Make sure you copy the objective. I'll give you some time for that. Also, if you aren't here and you're watching the video, I printed out study guides, so make sure when you get here, I'm leaving them on top of the iPad cart. Everybody here should have one by now. And like I said, today we're going to be working on graphs. But get a Cornell note ready. No sprayer mouth. Give you some time for that. All right. Hands up any more time? Okay, we good? All right, so our objective for today, I can master all semester 2 concepts and skills. I can master all semester 2 concepts and skills. Of course, algebra 2. So last time, yesterday, we left off and we started on what we left off the previous day, which was a system, solving a system in 2 variables, 2 equations using substitution. From there, we moved on to a 3D using elimination. From there, we moved on to solving a system using graphing. So I gave you guys example 7Q, and we solved that here by graphing it. And we said that the solutions were -2, -1, and -1, 0. And those were the solutions because that's where both graphs, what? Intersect. Is that correct? And I asked you guys to look at it through the, in regards to the first equation, we graphed it using slope-intercept form. The y-intercept is +1. The slope was 1 over 1. 1 up, 1 to the right. And remember, the denominator is always to the right. Once we graphed that, we focused on the second one, and I said we're going to look through the lens of transformations. And we used the general rule that we wrote. And we focused on the parent function f of x equals x squared and 3 points, which were 0, 0, 1, 1, and 2, 4. And from there, once we graphed it, there it was, and I left you guys this one for home plate, which was number 7. Is that correct? So I'm going to go ahead and do this one right here, and let's do it again. So copy that, please, so like that we can have it one more time. And it says, example 7S, solved by graphing. Now, at this point, if you want to use the study guide, it's on the study guide. Or if you want to do it again on paper, it's up to you. But you should have this one on the study guide, brand new, fresh, yes? All right, here we go. It reads, solve by graphing. So the first thing I want you to graph is the linear function. And you already have your coordinate plane ready in the study guide, so I want you to go ahead of me and do that by yourself. Graph the linear first. All right, so let's see. Hopefully you started with the y-intercept, which was what? +5. 1, 2, 3, 4, 5. There it is. And then The slope says 2, which is 2 up, and the denominator is 1 to the right. So you go 2 steps up, 1, 2, 1 to the right, plot your point, do it again, 1, 2, 1 to the right, 1, 2, 1 to the right, plot my point, and I can graph my line at that point. Now check this out. In order to go the opposite direction, instead of going 2 steps up, I'm going to go 2 steps down and 1 to the left. 1, 2, 1 to the left, plot my point, do it again, 1, 2, 1 to the left, plot my point, graph my line, okay? Let me graph my line. Something like that, yeah? Hands if you got something like that, yes? Okay. All right. For the second one, first of all, the parent function is f of x equals x to the second, because that's the exponent, yes? So what does that graph look like? It's a parabola. There it is. And what are the 3 points we're going to focus on? 0, 0. I'm going to start with that one. So imagine the 0, 0, it's right there. I'm not going to plot it, but it's invisible. And tell you never where I'm going to move this to. Tell you never where I'm going to move that point to. Three to the left and 4 down. So I'm going to go from here. I'm going to go 1, 2, 3, 1, 2, 3, 4. There it is. So I'm done with this point. What is the next point on the parent function? 1, 1. So I'm going to go to 1, 1. 1, 1 is right there. There's my invisible point, and again I'm going to move it 3 to the left and 4 down. 1, 2, 3, 1, 2, 3, 4. I'm done with this point. What is the third point on the right side of the parabola? It's 2, 4. So let's go to 2, 4. 1, 2, 1, 2, 3, 4. So I have an invisible point at that point. And I'm going to go 3 to the left. 1, 2, 3. And 4 down. 1, 2, 3, 4. We good? And then we need to reflect these to the other side. So there's a point from here, there's a point 1 up, 1 to the right, so there should be one up and 1 to the left. And then this one is 1, 2, 3, 4, and 2 to the right, so 4 and 2 to the left. Something like that. All right. So, according to what we see there, tell your neighbor the solutions to this system. Andres, pass them. Maya, give us one of the solutions. -4, 1, 2, 3, 4, and -3, 1, 2, 3. That looks about correct. It's about right there. -4, -3. Yes, that's one of them. Pass someone for the other. Andres, the other one. 0, 5. Hands if you got that. Looks about right. It's right there. And yes, those are my 2 solutions. Question. What's another way of checking that? Talk it over your neighbor. How can we check that without graphing? So we can check without graphing by solving using substitution or elimination. We're going to do that? No. All right? All right. So with that said, move on. So that was number 7 from the study guide. So now on your notes, we're going now into transformations and graphs. So at the top, I want you to write the general rule one more time for transformations. G of x equals a times f of 1 over b x minus h plus k. Make sure you label each parameter as to what it does. And once again, just for the sake of it, tell your neighbor what each of those parameters does to any function. What does each parameter do to any function? All right, so if we substitute for k a positive, it goes upward. But if it's a negative substituting in there, it's downward. If we substitute a positive number for h, it goes to the right. But if we substitute a negative number in here, it goes to the left. And now check this out. This is where some of you make a mistake. Look up. Whenever we substitute a negative number in for h, it goes to the left, which means this becomes a positive. By now it should be clear, but I'm clearing this up right now. A stretches vertically or compresses vertically. B stretches horizontally or compresses horizontally. Yes? Okay. So, with that said, let's make a table. Let's start with the first column and call it parent function. All right, so who can give me the name of the first parent function that we covered for the school year? Tell your neighbor first. What is the first parent function? All right. That's the sound of your noodle, like doing all the thinking. Let's see. Andres, pass someone. Hector, first parent function. Yes, f of x equals x, which is a linear. Now, the next column, we're going to show the graph. That graph is a straight line like this. Okay, however, this is a positive. Next to it, I'm going to write a negative. And you should know how that looks like, yes? Yes, Mr. Q. And no, I'm not talking about your friends. I'm talking about the line, negative. Do any of you have some negative friends? Like, they're always saying negative stuff. It's like, come on, my goodness. Ah, here's a chocolate or something. All right. So, things to know. Here we go, right here, quadrant, or quadrants. And then start, finish. So for the positive one, right now I'm going to focus on the positive. What quadrant does that one start at? Tell your neighbor what quadrant. And by the way, the quadrants, I'm talking about the coordinate plane. 1, 2, 3, and 4. Tell your neighbor where it starts and where it ends for the positive. Yeah, so for the positive, and right now I'm only going to answer this for positive, and we know for the negative it's going to inverse, but for the positive it starts in quadrant 3, and it always ends in quadrant 1. Why? Because the arrows continue and they keep going. So the line will be here, 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 you know, somewhere, but with the lines that keeps extending. All right, and the last column. Question, what is the exponent? What kind of exponent does it have? Did I hear 0? Tell your neighbor what exponent goes there? 1. What kind of number is 1? Exponent. It's an odd exponent, yes? All right. Let's go to the next one. Hector, pass it to someone so they can give us the next function, parent function. Chantal, f of x equals x squared. Chantal, let's go. Yeah, x squared, and this is a quadratic. Tell your neighbor what that graph looks like. Positive and then the negative. Yeah, it's a parabola. It's a happy face for the positive. And if it's a negative, which means a negative coefficient here next to the x squared, it would be a sad face or an upside down parabola. Once again, I'm going to focus on the positive parabola. Where does it start, what quadrant, and where does it end? Tell your neighbor, please. Where does it start, where does it end? Yeah, it starts in quadrant 2, and it ends in quadrant 1. And what kind of exponent shall we say? Even. All right, let's go to the next one. Chantal, pass someone. Andres, f of f of x equals exponent 3, which is a cubic. Thank you, Andres. Yeah. And that graph, starting from the bottom to the top, looks like this, like a little wiggle. The positive. And of course, for the negative, we start at the top, going downward. All right, so for the positive cubic, quadrant starts at what? 3 and finishes at 1. Okay. What kind of exponent? Odd. All right. Hopefully this review is helping you guys think it through. Yes, because we're going to be looking at graphs with this information. All right. Andres, pass someone for the next parent function. Chantal, f of x equals x to the 4th. Yes, this is a quartic. Quartic. And it looks like this. Kind of like a parabola, but a little bit elongated from the bottom. And of course, the negative, same thing. Elongated. And it starts where? What quadrant? 2, and it ends at? And this is an even. Before I continue with the rest, can you wrap up this idea to your neighbors? Let them know in regards to, if you look at a graph and look at the exponent, do you know where it starts? Do you know where it ends? All right? Talk it over to your neighbor, let them know. All right? So, next. Pass someone, Chantal, next parent function. Andres, f of x equals x. How about 1? That was a good one. 1 over x. All right, this is a rational. And this one looks like this. First, the coordinate plane. Here it is. And at the coordinate plane, remember, these were asymptotes. These are like dotted. And then our graph is here and here. And this is a positive. And of course, if we do the negative, instead of starting up here, this one reflects down here, and this one reflects on this side. Question, what is the exponent on this variable? 1, okay, which is what kind? Odd. So therefore, where shall I start? 3 for the positive. It starts at quadrant 3. Does it have something at quadrant 3? Yes. How about quadrant 1? Yes, there it is. All right. Next, f of x equals 1 over x squared. This is also a rational, that's why I'm leaving it like this. And then this one, though, here's my asymptotes right here, right here. Before I graph it, what kind of exponent do we have now, everyone? Even. So where do we now know it's going to start, and where does it end? 2 and 1. So let's see if it's true. This was known as a what? J-low. There it is, J-low. Do we have something on quadrant 2? Yes. Quadrant 1? Yes. This is for the positive. Now I'm not going to graph the negative because you know what it does. It just flips it over, right? Are we doing? Yes? Okay. And then from there it starts getting a little bit more funner by the minute, but we'll get to those. I just wanted to get us started and understand what we're looking at with that. Okay? All right, so with that said, get your study guide in front of you. Hopefully that's a good review for transformations and graphs. So let me get my study guide, which brings us to number 8. Let me zoom in. It reads, write a function that transforms f of x equals x cubed by a vertical stretch of a factor of 2, shift of 4 units to the left, and shift of 3 units down. So first of all, without looking at your notes, turn to your neighbor and let them know the general rule for transformations. What's the general rule? General rule. Let's see. All right, so you should have said general rule is A times, now I'm not going to use the F anymore, parentheses, X minus H plus K. The only thing I'm missing is 1 over B. However, since they didn't say stretch horizontally, this is a what? So I don't need to use B for right now. So with that said, what do I write here? 2. How about for H? 4 units left. What kind of number am I going to substitute here? Left. -4. That is correct. How about shift 3 units down? What do I write? -3. Okay, so now I just need to rewrite this. G of x equals 2 parentheses. X, negative times the negative is a positive 4. Don't forget the exponent because now it's applied to what kind of function? a cubic, and then at the end, minus 3. Answer. C? D. Hey, that's a good idea. If you need to. Like for these guys, I know some of these we can do in our noodle once we get plenty of practice, but there it is. Okay? All right, let's move on. Number 9. Do we need another example of this? Okay, let's move on. Bless you. All right, let me zoom out. It says, look at these graphs, guys. It says, which is a graph of an even function, think about that one, even function, with a positive leading coefficient. So it's a positive, even function. Talk it over to your neighbor, let them know which one of those. First of all, start, which is the even one? Which is the even function? Which means, where does it start? Where does it end if it's an even function? All right, even functions start where and end where, Bella? Starts at 2 and end at 1. So let's see. Which one? Not this one. No. So let me cross that one out. Hold on. Because this one's not starting at quadrant 2. This one's starting at quadrant 2, but it ends in quadrant 3. No, in quadrant 4, so that's not it. So look at these. Quadrant 2 and ends in quadrant 1. Okay, so, in case you don't see it, quadrant 2, quadrant 1. Do you see that it starts here and it ends here? Yes? How about this one? It ends in 4 and then starts in 4 and ends in 3 and ends in 4. No, it's not that one, so it has to be B. Yes? That's it. Yeah. And yes, by the way, I'm leaving the final as a multiple choice. Thank you, Mr. Q. You're welcome. All right. From 1 to 5, how comfortable are you identifying the type of graph? Yeah, with a review, hopefully that helped. Let's move on. Number 10. Let me zoom out. It reads, graph f of x equals x cubed plus 6x squared plus 9x. Identify the intercepts and give the domain and range. Okay, so I'm going to start with this one, and I'm going to focus first on the equation. So let me zoom in for that. Where is it at? All right, so on your paper, I want you to, on your notes, write number 10, and I want you to write this function, f of x equals x cubed plus 6x squared plus 9x. From this point forward, when they're asking you to graph using intercepts, basically what they're asking you to do is that you need to factor completely that function. Tell you never what we need to do? Yeah. All right. So here we go. You wrote down f of x equals x cubed plus 6x squared plus 9x. First things first, we need to set it equal to 0 equals x cubed plus 6x squared plus 9x. First things first, let's check to see if there's any GCF. Is there any GCF? Yes, an x. That is correct. And that leaves us with x squared plus 6x plus 9. And all that equal to 0. Am I done factoring? No, look at this one. Tell your neighbor what to do with this trinomial, please. Yes, so we got 9 on top, 6 on the bottom. What factors of 9 add up to 6? 3 and 3. So my factors are x plus 3, x plus 3, and this is x. Set it equal to 0. Am I done? No. Now that we have 3 different factors, what do we do? Tell your neighbor. What do we do with each of those factors? Yeah, set them equal to 0 and solve. So therefore I write x equal to 0, x plus 3 equal to 0, x plus 3 equal to 0, and we solve. This one's already solved. Minus 3 minus 3, x equals negative 3. Minus 3 minus 3, and this is exactly the same as the other one, negative 3. All right, before we select our answer from the study guide, let's graph this together. So on the side, I want you to make a coordinate plane, because some of us probably forgot how to graph these. And by the way, what's the highest degree of that function, guys? 3. So what kind of function is it? Let's see, it's an odd function, right? Odd function? Okay, so where does it start and where does it end? Starts over here somewhere, so it starts over here, and it ends over here. So keep that in mind when we're graphing, yes? So let's plot our intercepts. 0. There it is. Negative 3. 1, 2, 3. There it is. So I'm done with 0. I'm done with negative 3. But here's another negative 3. Look what I'm going to do. Why'd you do that, Mr. Q? Because that serves a purpose. Here it goes. So we're going to start down here because it starts at 3, right? So we're going to go first from left to right. Since this one's a double root, it doesn't go through. It just bounces off. And then it goes through. Look at it. Does this look like a cubic function? Look at the graphs that we just did. Does it look like a cubic function? Yes, because the highest degree is a what? A 3. So with that said, look at the options that they give us. So, answer. Which is our graph, guys? A. So do we really need to focus on anything else? No, there it is. So answer A. So for this one, the only thing that you're going to have to show is the work to find the roots so that you are for sure which one is the graph. All right? Move on. Let's go to number 11. 11. Okay, on your, I don't know if you have space next to it or below it so you can write the polynomial again. Write this polynomial. P of x equals x minus 1 times x plus 1 times x minus 4. Either write it on the side or on the bottom so we can do some work with that. So once again, if we were to graph this, we need to get our roots, which means we need to set this one equal to 0, x minus 1, x plus 1, and x minus 4. Yeah. And notice they already did the work for us, right? So you know what to do from there, please? Yeah, set them to 0. X minus 1 equal to 0. X plus 1 equal to 0. X minus 4 equal to 0. Plus 1 plus 1. X equals 1. Minus 1 minus 1. X equals negative 1. Plus 4 plus 4. X equals 4. So these are my solutions. X-intercepts, roots, zeros. So now that we know these, now before we move on to the graph, look at it. How many roots did we find? So what would be the parent function? Tell your neighbor the parent function for this one. F of x equals what? F of x equals what? X to the third, because there's only 3 roots. So that means our graph starts where? Tell your neighbor, please. It starts at 3 and it ends in 1. And it has to go through these 3 roots. So look at the options, talk it over your neighbor, see if they have the same answer as you. Your graph has to go through 1, negative 1, and 4. Answer. Wait a minute. They're all cubic functions, right? Yes, they are. Except for these are negatives, aren't they? Because they're going the opposite direction. So it can't be these two. Oh, sorry. It can't be this one because it's starting up here and it goes downward, or that one. So it's going to be one of these two. So what were our roots? 1. Let's see, this one has 1, and this one has 1, yes. What else? -1. This one has -1. This one has -1, yes. +4 or -4? So the answer is B, yes. So be careful. Be careful with these, yeah? All right, how are we doing with graphing, yes? All right, let's go to number 12. All right, so this is, first of all, before we go to the answers, look up to the screen. Look at this graph. Let me zoom in. Where does it start and where does it end? Tell your neighbor. Quadrant 2, and then it ends in quadrant 1. That means this is an even function. Okay. However, let's see. What are the roots? Okay. Before we go down here to the options, tell me the roots by looking at the graph. Oh, hold on. Let me. Okay, there it is. So the roots are what? -1. Wait, you're moving on too fast. You'll notice that this one did not go through. So that means x is -1, and then x is -1 twice. That's why it bounces off. So how many -1s? 2. All right. Then 2, so we got x equals 2. And what else? 5, x equals 5. So how many roots do we have? 1, 2, 3, 4. Is it an even function? Yes, we started on 2 and then in 1. So be careful with these. Look up, please. Make a little note for yourself, asterisk, and make a note here. Write whatever note you want to write. Remember that when it doesn't go through, it's 2 roots. 2 roots. And point to that when it doesn't go through the x-axis, okay? So now with that said, let's go to the options that they give us. What are the options? Let me zoom out. It says, which of the following polynomial functions could have the same, could have the graph shown? All right, so let me move this up. We said this is x equals -1, x equals -1, x equals 2, and x equals 5. So look at these. This is a +5, yes? But what was it before we solved it? X minus 5. Okay. So which one has x minus 5? This one and this one. So these are out. Okay. How about this one? X minus 2. Which one has x minus 2? Both of them? Oh, okay. And then this one? X plus 1. Yes. How many times? 2. So the answer is D. Be careful with those, yes? You all right? Yeah? Some of you are like, all right, and bless you. And I think the last one, look up. What kind of function? Odd or even? Odd. Okay, so it looks like a cubic. Bless you. What are my roots? -2. What else? +1. +1. Why? Because it doesn't go through. It just bounces off. So this is a double root. So which is the answer for this one? Tell your neighbor, please. Answer is D. That is correct. let's go. For tonight, home play. I'm going to even write it here. Home play. You need to go through numbers 8 through 13. Tell your neighbor which ones? Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye.